So in our first lecture, or our last lecture, depending on how you want to look at it, we defined some important physiological terms, including physiology. Now we're going to discuss homeostasis. Now, in order to understand homeostasis, we also need to understand feedback loops. So this leads us to homeostasis. When it comes to physiology, the goal is to maintain homeostasis or return to homeostasis if we are out of homeostasis. One way to think of homeostasis is to put your body in a position to maintain life. Okay, this requires a stable internal environment. However, it is important to know that stable does not mean static or constant. Homeostasis is a dynamic equilibrium. In other words, for most variables, there is an acceptable range we can be in. Homeostasis, however, requires tight regulation, which is accomplished with feedback loops. So let's look at feedback loops. So feedback loops are composed of a receptor. So a receptor is going to get some information about a variable. Okay, let's talk about body temperature. So a receptor, in this case, a thermoreceptor, is monitoring core temperature and is constantly sending information to my brain. My brain is not only receiving information from thermoreceptors on my skin, but internal thermoreceptors as well. My brain then integrates or takes into account all of this information it's receiving to make a decision. In this case, because we're going to assume I'm at a normal temperature, it sends a signal to an effector, such as my sweat glands, and tells them they don't need to do anything. However, oftentimes a response is warranted, and depending on the kind of response, this will enact a positive or a negative feedback loop. Now, a negative feedback loop is one where effector activity opposes the stimulus. The feedback loop will turn off once conditions are back to normal. However, a positive feedback loop is one where the effector activity is in the same direction as the stimulus and continues to amplify the change. A positive feedback loop will continue until the stimulus is removed. Finally, we need to understand the difference between equilibrium and steady state. Equilibrium is where the system itself is stable. The physiological variables are constant. While it seems like the same thing, steady state is a little different. When you're at steady state, a specific variable is constant. However, other variables might be changing to maintain that first variable. And we're going to talk a lot about steady state as we go forward in the semester. So to help review, see if you can answer these 4 questions. Are you able to define homeostasis? Can you describe the differences between positive and negative feedback loops? And while I didn't talk about it, are you able to provide an example of a negative and positive feedback loop that occurred during exercise? And finally, can you describe the difference between steady state and equilibrium?